Factor by grouping. X squared minus 4x plus 3x minus 12. I'm going to start by rewriting this polynomial down below, so I've got more room to work with it. And we can see now that we're factoring by grouping. The last lesson involved factoring out the greatest common factor. We could try that here, but if you look at x squared and negative 12, those terms don't have anything in common except for 1, so there's nothing really valuable that we can pull out. So in this problem, if we were asked to factor out the GCF, there'd be nothing we could do. But that's why we are learning this new method, grouping. So grouping will work in this case. What we're going to do is we're going to take the 4 terms and we're going to split them up into 2 groups. We're going to look at the first group and the second group, and we're going to factor each of these groups on their own. So for now, just focus on the x squared minus 4x. If we look at those terms, we see that they both have an x in common. X squared and negative 4x are both divisible by x, so we can pull out an x. When we pull out an x, the leftovers are going to be x minus 4. So that first group did have a GCF that we could pull out. Let's look at the next group, and we've got a plus in between. We've got 3x minus 12. Well, both of those have a 3 in common, so we can pull out the 3. And then when we pull out the 3, the leftovers are going to be x minus 4. 4 because 12 divided by 3 is 4. So each of these groups we could factor, we could pull out the GCF, and when we've done that, we hopefully notice something interesting. If you look at the 2 groups, each one of the groups has a factor of x minus 4. I call it a factor because it's being multiplied by the x and it's being multiplied by the 3. So both of the groups have a factor in common. I hope you see where this is going. Whenever we have a common factor, we usually pull it out. So what we're going to do is we're going to pull out the x minus 4 from each group because that is the greatest common factor now of the 2 groups. And when we pull out the x minus 4, we have to see what's left over. In the first one, if we get rid of the x minus 4, we're left with the x. So the first leftover is going to be x. And then in the second one, if we pull out the x minus 4, the leftover is a positive 3. So it's going to be x plus 3. And in the end, we have a factored version, x minus 4 times x plus 3. Whenever we have a factorization that we want to check to make sure that it's correct, we multiply it out. And in this case, if we want to multiply x minus 4 times x plus 3, we've got a binomial times a binomial, so we FOIL. Let's multiply it out. If we look at the product of the first terms, x times x is x squared. If we look at the outer terms, x times 3 is going to be 3x, so we've got plus 3x. If we look at the inner terms, negative 4 times x is going to be negative 4x, so we've got minus 4x. And then if we look at the last terms, negative 4 times 3 gives us negative 12, so we've got minus 12. And if we compare this to the original polynomial that we had, they are equivalent. The negative 4x and 3x are in a different order, but it doesn't matter. They are equivalent polynomials, which tells us that we have factored correctly.